Welcome back to Algebra 1, Chapter 9, Section 1 in this book. So what we're going to be talking about are quadratic equations. And if something is a quadratic equation, it will have a variable squared in it, which is always confusing to me because it's squared, but it's quadratic, which sounds like 4. So don't you get confused too. Quadratic equations have a squared in them, all right? So we can solve it sometimes by doing square roots. Now, what is a square root? The square root is the opposite of squared. So if x squared equals 25, we can figure out what x equals. Because why is x not alone? It's being squared. What's the opposite of squared? Square rooted. I'm sure it's a word. What you do to one side, you do to the other. Now, what is the square root of 25? I don't remember if I've taught you this or not, so I'm going to teach it again. Square roots, I think of as Arkham Asylum for the criminally insane in Batman. Okay? So this is Arkham, and the only way to get out is by having an identical twin like Mas and Minos. Okay? And so if we did a factor tree of 25, 25 is made out of 5 times 5. Remember when we did factor trees? You probably did them back in middle school too. So that it's got an identical twin. You kill your twin, dissolve the body in acid. Remember, it is the home for the criminally insane. And then you get in the body bag, zip up, play dead, and Bob's your uncle, out you go. You get out. So how to get out of jail is by having a twin. If this was, say, 75, which is made out of 3 times 25, and 25 is made out of 5 times 5, a 5 would die, a 5 would get out, and a 3 would stay in jail. I usually draw a box around that and draw little things. So this would be 5 times the square root of 3. This one stayed in jail. So that's sort of a little review of how squares and square roots work. Now, in your book, and when you do this in real life, sometimes there's 2 answers that can be here. So let's do this. What is the square root of 9? Well, 9 is made out of 3 times 3. So this one dies, this one gets out, and the answer is 3. Or is it? Couldn't this 9 also have been made out of negative 3's? Isn't negative 3 times negative 3 also 9? So sometimes in your book it will say what's the square root of 9 is 3. Sometimes they want you to write plus or minus 3. That it could have been 2 plus 3's that were multiplied together, or it could have been 2 minus 3's that were multiplied together. The problem is we didn't buy the origin comic. We don't know if this 9 is a hero, like when Jim Gordon got sent to Arkham, or if it's a true villain, like when Penguin got sent to Arkham. We didn't buy the origin comic, we don't know if it's plus or minus 3. This symbol that means take the square root is called a radical, which I always think of like the 80s. Radical man, radical dude. That's what Bart Simpson used to say when he first came out. Alright, so here's another one. So at this point in your book, they are just saying the square root of 9 is 3. It's the opposite. What is the square root of 64? Well, 8 times 8 makes 64. This one dies, that one gets out. What about if it says negative 64? Then we know that this one dies, that one gets out, and there's still this times an understood negative 1. And 8 times understood negative 1 is negative 8. What about the square root of 0? Well, 0 is made out of 0 and 0, isn't it? 0 times 0 is 0. Square root, plus or minus the square root of 0.25. This time they want us to write the plus or minus sign. So, the square root of 25 is 5, so we know the square root of 0.025 is plus or minus 0.05. Now, With one like this, I would do it on my calculator. I wouldn't just trust my brain because I'd probably get it wrong. So you're welcome to do these on your calculator. On your calculator, it is the second of squared. Do second x squared and it will give you the radical sign. Square root of -4. What's the answer? No solution. Because there are no twins that make -4. There's only 2 times -2 is the only way to get -4. This was the answer when I was in high school. Now there's this whole thing called imaginary numbers, but right now in your book this is the answer too. We will talk more about imaginary numbers when you get to Algebra 2. Alright, so right now this is the answer. No solution because there are no twins. 121 is made out of 11 times 11. It has a negative on the outside, so they want it to be -11. 144 is 12 times 12. So, but they have a negative on the outside, so it is negative, and I think it's is it 1.2? See, I'd have to do this one on my calculator to make sure. Maybe it's 1.2. I'll cheat and look in the book. Let's see what it is. 144, I was right, 1.2. Same thing with this one, 0.09, because it's kind of weird, I would probably do it on my calculator. But it is equal to 0.3. And they didn't want a plus or minus. This one is the square root of 7. I want you to do it on your calculator. Pause the video if you need to. And you will see it's not a nice little number. It's this weird decimal that goes on forever because it is an irrational number, the square root of 7. Meaning it goes on for decimals forever without repeating and getting a pattern of repeating. So we can't say the answer, we can only say it approximately equals, the curvy equals 2.65. Because of this, this is the answer that you're supposed to put on your paper. The square root of 7 is the square root of 7. Because this is not an answer, it's an estimate, and this is more correct. This is a correct answer, this is an approximate answer. Unless they tell you to use a calculator or round your answer to 2 decimal places, you're supposed to do that one. Now, one kind of problem they have is this one. It's substituting numbers into a radical expression. We have the square root of b squared minus 4ac. That's an important little equation. It's called the discriminant. We'll learn more about it later. But all you do is sing the song, substitute. And then where there's a b, put -2. Where there's an a, put 1. And where there's a c, put -3. Put it in your calculator exactly like that. You should get the square root of 16, which is 4. Okay? A quadratic equation has a variable squared. Sometimes the quadratic equation looks like this. It could be something like 2x squared plus 3x plus 2 equals 0. It looks like that. But to be a quadratic, sometimes it has an x squared and an x and a bare number. But not always. To be a quadratic equation, it just has to have the x squared. So a lot of times it has the other things too, but it doesn't have to have it. The number that goes with the x squared has a special name. It's called the leading coefficient. The number that goes with the x is just a coefficient, a lowly coefficient. And the letter that is a bare number is called the constant term. I call it the bare number. Sometimes you say this equals 0. Sometimes it will say it equals y. Sometimes it will say it equals f of x. Because weirdly, they're all the same thing. I'll explain to you why later. So, you can have this equation, x squared, and we can solve it. Why is x not alone? It's squared. What's the opposite? Square rooted. What you do to one side, you do to the other. What's the square root of 4? 2. How about this one? Why is x not alone? It's squared. So what's the opposite? Square rooted. What you do to one side, you do to the other. Square root of 5 is an irrational number, so the answer is just square root of 5. Why is x not alone? It's got a squared. What's the opposite? Square rooted. What you do to one side, you do to the other. What's the square root of 0? 0. Why is x not alone? It's squared. What's the opposite? Square rooted. What you do to one side, you do to the other. What's the square root of -1? Not allowed. Undefined. No solution. I always like that. Okay, here's a problem that we can solve. Why is x not alone? Well, it's got a 3, a square root of 48. We're going to work from the outside in. The opposite of minus 48 is plus 48. What I do to one side, I do to the other. Bring down what I didn't mess with. That's a squared. Now divide by 3. So x squared equals 16. Square root both sides, x equals 4. Where they do these problems, where you use them in real life in the math books, is the height formula. If you drop something, you can figure out how long it will take to fall to reach 0. So 0 is when it hits the ground. S is how tall it started, and T is the time. So here we have a problem where you're going to start at 32 feet, we're going to drop something, when's it going to hit the ground? We fill in 0 for H, 32 for where we started, and we start doing the opposite. Minus 32 to both sides, then divide by -16 to both sides, then square root both sides, and the time is the square root of 2, which is about 1.4 seconds. So if you drop something from 32 feet, it'll take about 1.2 seconds unless it has a light air resistance. A feather could take longer. All right, math is great. See you next time.